finally we are done with the theoretical discussions related to relations on a set. Now it's time to solve practical questions and especially MCQ questions. Here is your first question. It says, let A and B be two sets such that A cross B has 6 elements. If 3 elements of A cross B are 1, 4, 2, 6 and 3, 6, then what are A and B set? So just focus on the first line. The A cross B has 6 elements. So the cardinal number of the power set is given as 6. So it can be 1 into 6, it can be 2 into 3, it can be 3 into 2, it can be 6 into 1. What do you mean by all this? That is, the set A can have 1 element and set B can have 6 elements. Then the product set will have 6 elements. Similarly, 2, 3, 3, 2 and 6, 1. In all these cases, we are going to get the cardinal number of the power set as 6. The second part of the question says that the 3 elements out of 6 are 1, 4, 2, 3, 2, 6 and 3, 6. So just focus on the first elements, that is 1, 2 and 3. So it is clear that the set A, that is the first set, must contain the elements 1, 2, 3 at least. And the second set or the second elements are 4, 6 and 6. That means the set B must contain the element 4 and 6. Otherwise we can't get 1, 2, 3 as the first element of these ordered pairs and 4 and 6 as the second element of these ordered pairs. So these are the most probable answers for set A and set B, and in this case the cardinal number is 3 and it is 2, and product of these two results to 6. That is the cardinal number of the product set. So these two sets satisfies all the given conditions in the question. So option C is the correct answer. The second MCQ question, it says S is a relation over the set R of all real numbers, and it is given by A, B belongs to the S with the relation set defined as AB is greater than or equals to 0. Then S is. So the given definition is S is equals to A, B such that AB greater than or equals to 0, A, B belongs to real number. Now we'll check that is this given relation S reflexive, symmetric and transitive or not. If we take any real number, for example A, it can be positive or negative, anything. If it is positive, then A into A is always greater than or equals to 0. Even if it is negative, then again the product with itself is going to be greater than 0 again. So whatever be the value of A, for all A belongs to R, A will be related to A when the definition is A into B is greater than or equals to 0. So the given relation is reflexive. Now check the answers. This option says symmetric and transitive only. We have not checked it yet. A partial order relation, not relevant. Reflexive and symmetric only. An equivalence relation. So we have to check is it symmetric or not. To check the symmetric relation, we need to consider two elements from the real number set, or consider two real numbers. If a into b is greater than or equals to 0, it is possible when both a and b are positive and both are negative. Then b into a is also going to be greater than or equals to 0. That is, if a related to b, then b is also related to a. That means the given relation is symmetric. Now, is it transitive? If it is transitive, then option D will be the correct answer. If it is not, then option B will be the correct answer. For that, we need to consider three real numbers such that a is related to b and b is related to c. That means ab greater than or equals to 0 and b into c is also greater than or equals to 0. Now, if this product of these two numbers is greater than 0, then either both of them are negative or both of them are positive. Same for these two. If b is negative, then c has to be negative. If positive, then c has to be positive. Now, if b is negative here, then it will also be negative here. So when b is negative, a and c, both of them are negative. When b is positive, a and c, both of them are negative. That means a into c is also going to be greater than or equals to 0. That means a is related to c. So the given relation is transitive. Since it is satisfying all the three types of relations, that is reflexive, symmetric and transitive, so the given relation is equivalence. Option D is the correct answer. Question number 3. Let S be the set of all real numbers. Then the relation R is equals to a comma b such that 1 plus ab is greater than 0. So this is the definition of the relation here. Now, is this relation reflexive? For that, let us consider a belongs to the real number set S. So whatever be the value of a squared, that is a into a, is always greater than 0. That means 1 plus a squared will also be greater than 0 for all a belongs to the real number set S. So the given relation is reflexive. Now, is it symmetric? For that, consider two real numbers a and b. If 1 plus ab is greater than 0, it is possible if both the real numbers are positive or negative, then the product is going to be positive. So 1 plus some positive number is going to be greater than 0. Then 1 plus b into a will also be greater than 0. So even if we change the order, the product is going to remain the same. That means 1 plus ab and 1 plus ba both will be greater than 0. That means the given relation is symmetric. Now, is it transitive? For that, we need to consider three real numbers a, b and c. And we are assuming that a is related to b and b is related to c. Now we need to check, is a also related to c? If we consider some numerical examples for a, b and c, for example, a is equals to half, b is equals to minus half and c is equals to minus 4. You can see that here 1 plus ab, which is equals to 1 minus 1 by 4, is greater than 0. That means a is related to b. Similarly, 1 plus b into c, which is equals to 1 minus minus plus 2, is again greater than 0. That means b is related to c. But 1 plus ac, which is equals to 1 minus half into 4, that is 2 and it is going to be less than 0. That means A is not related to C. Even if A and B is related, at the same time B and C is also related. So A, B, B, C both belongs to R, but A, C doesn't belong to R for this particular values of A, B and C. So the given relation is not transitive. So option A is the correct answer here. Question number 4. Let W denote the words in the English dictionary. Define the relation R by R is equals to X, Y such that the word X and Y have at least one letter in common, and X and Y belongs to the English dictionary, that is the W set. Then R is, we are considering the same word. For example, consider the word and. So the given relation is defined as the words must have at least one letter in common. If we consider the same word, all the alphabets or the letters are common. So it satisfies the given definition of the relation. That means and is related to and. In the same way, each and every word in the set W are related to itself. That means the given relation is reflexive. In second case, suppose ant and apple. In these two words, A is common. That means these two words satisfies the relation defined as at least one letter in common. So ant is related to apple, and we can also say that apple is related to ant in the same way because A is common there. That means if any word A is related to B, it will lead to B is also related to A. That is symmetric. Now in the third case, ant is related to apple and apple is related to. Now in this case only one alphabet is common, and in this case two alphabets are common. So both of them satisfies the definition of the given relation. Now can we conclude that ant is also related to X? And yes, we can conclude that because A is common there. So if there is something common between this alphabet, this word A and this word B, and again there is something common between B and C, then it is obvious that there will be something or at least one alphabet common in A and C. So the given relation is transitive. So finally we can conclude that the given relation is reflexive, symmetric and transitive. So option D is the correct answer. Question number 5. The relation on a set A. The set A is given as A is equals to X such that mod of X lesser than 3, where X belongs to Z. So we need to choose the integers that will satisfy the given condition, and those integers are -2, -1, 0, 1 and +2. Any integer greater than +2 or lesser than -2 will not satisfy the given condition. Now, the relation R is defined on this particular set A such that y is equals to mod of x. That means the second element of the ordered pair is equals to the mod of the first element. So such ordered pairs can be -2, 2, -1, 1, 0, 0, 1, 1 and 2, 2. In all these cases, the second element is mod of the first element. But along with the definition, there is a condition that x can't be equal to -1. That means this ordered pair can't be a part of the given relation. So we need to remove this element. So in total, the cardinal number of this relation R is 4. Now in the question, we have been asked the number of elements in the power set of R. So total number of elements in the power set is given by the formula that the number of product of the number of elements of the sets participating in the product. Here we are taking the power set of R, that means R into R. The number of elements of R is 4, so cardinal number of the power set will be 4 into 4, that is 16. So option B is the correct answer.